Uh, I do want to just kind of cover the basics of fire investigations and things to look for, things about what to be aware of. It's going to be less about the investigation that you could go into, all the different aspects of looking for arcing or charring um, in different areas, because to be honest, the vast majority of the students who ever takes this class as law enforcement students aren't going to get uh, into arson investigation or fire investigation um, at anywhere near the rate of, say, fire science students or anything like that. Now, it doesn't mean you can't, and doesn't mean you won't ever, because there are ways to get to become certified fire and explosion investigators. But with the time constraints that we have, and knowing that most students are not going to go the route of true arson investigation, whether it be through, um, for example, the state fire marshals. Okay, although they do have arresting powers and are considered a law enforcement agency, it is usually investigations are usually handled through the fire department itself, or at least they have investigators working on that department or connected to them that way through the state. So that being said, we can go ahead and get into some things as far as what we'd be looking for. Some simple things to begin with would be this right here: the components of fire. A lot of times, for years, they used to have um, the fire triangle, in essence, that you would need heat, oxygen, and fuel. That's true, but they've also added the fourth element of a chain reaction or continual chain reaction, and that's turned it into the fire tetrahedron. So yes, you can have uh, fire, or at least consumption of something without visible light. You have rust technically is a form of combustion. Okay, very slow process. Char, the same thing. If you have sometimes char can actually be um, just as hot or hotter than what a flame would be. So that's something that it is all part of fire, but we typically see it emitted as energy in the form of light or fire, right? So, but yeah, those are the overall components. And when it comes to fire suppression, doesn't matter whether you view it from the fire science side of things or law enforcement. There are the main goal, if there's a fire, even if you're at home, excuse me, and not working either of those areas, something happens. The best way to stop a fire is to uh, either lessen or decrease, being another way of saying decrease the amount of uh, available, what you and I would consider fuel or something that can burn, or removing something from this um, tetrahedron. So um, a lot of times, what adding water does a couple different things, but for the most part, it decreases the heat. It also changes an exact, like access to oxygen, even though yes, fire itself produces one of the byproducts of fire is um, actually water. So interesting enough, it's usually in the form of steam, and it usually gets separated out into um, oxygen, hydrogen, but nonetheless, steam and all that is actually a process, one of the products of fire. So people don't realize that, but a lot of it is because fire itself, when we see it, typically what we see outside of the flame, but if you have smoke, excuse me, if you have smoke, what that is indicating is, especially the gray or dark, even black smoke, that's usually indicating incomplete combustion, because you have little bitty particles of whatever is burning that's not completely getting burnt up. So therefore, that's what gives it that dark appearance. Whereas if you have what we call a clean burn, and everything that is combustible is actually burning through completely, it will come up with a almost a white. Um, smoke. Okay, and in fact, you can try it sometime. Unfortunately, I don't have a video of this for this particular class or this lecture, but one thing you can do, I think it's kind of fun, is if you light a candle and then let it burn out, whatever, or snuff it out to where you just have the a white smoke that's leaving the wick, right? If it's pure enough, or in essence light enough of a white color, you can take that, like take a match or take a lighter and actually light the smoke, uh, what appears to be smoke, and the smoke goes back, the flame goes back down to the wick and can reignite the wick. So that's something that I kind of want to talk about, and it kind of gets us across, or gets the point across of the dangers that we face. Yeah, firefighters face it. So do we when we come to certain calls. It's not always, well, what fuel, like say, whether it be an accelerant like gasoline, diesel, alcohol, um, and other chemicals along those lines. Yes, they burn, but it's not burning the way that you and I, or at least most people, would view it. It's not like it's that substance that's actually burning. What we usually see, something, if you get a chance, I think it's a great way to see what we're talking about. If you have a if you get an opportunity to do this, take something like, wouldn't use gasoline, that's a little too volatile, but you can use diesel, you can use alcohol itself. If you have pure enough alcohol, you might need something a little bit stronger than the isopropyl alcohol that you get. Um, but either way, if you can get that, methanol is easily, you can find that almost anywhere. But either way, put that into a clear container, like say glass. Don't do it in plastic because plastic just melts. But clear glass or something like that to where you can actually light it. You can even set it on top of uh, a solid object. Maybe it's a block of wood or something like that. Maybe even concrete if you don't mind your concrete getting a little charred. Um, but what I was going to say is put that on there, light it, but do it in a place where it's dark, or at a time when it's dark. And what you'll actually see, if you have it in a liquid, like I said, if you put it in a glass um, container or a vase or something like that, and you put that ethanol in there, or methanol, okay, you light it, have the and view it from the side, and what you'll end up seeing is that there's going to be a little bit of gap between the liquid and the actual flame. So really, what it's expressing is, in most cases, it's the air, when the air mixture gets correct to make uh, to ignite the air, to show or express itself, express that energy through light or fire. Okay, it's like I said, it's the air that is usually on fire, even though that heat is causing a chemical reaction to burn uh, the actual element that you have, the solid that may be there. However, it's the uh, it's the air that you're seeing that is truly burning, kind of like the whole idea with a candle and a wick, right? So you have the oil product that is wax in the solid form. As the oil heated up, it turns into a liquid. That liquid naturally gets drawn into the wick, and then eventually what happens is you will that that I was going to say fat 'cause that's what it is, but either way, once that oil comes up, okay, and then it gets to a state where it's no longer a liquid, but going to turn into a gas, that's when it ignites, and that's when we see it as a flame, like in a candle, for example. Okay, so enough about that, at least for the time being. Um, we can talk a little bit more about fire itself and things to do with investigations. Okay, so whoops, there we go. Wasn't wanting to cooperate for me. Apologize. So here's some examples here. Basic thing, like it's almost what I would consider. Uh, Fire 101 type of things. So let's look at the picture on the left first. First of all, what you will tend to see, like some people might look at that picture and think, okay, well, based on where the green arrow is pointing, this area right here, that must have been, that's just, maybe that was happenstance, right? Um, maybe that, maybe the fire burned down because this is a stove top, right? And the person tried to claim that they had left something on the stove and it started a fire, and that's why you see all this damage up here. Okay, and like I said, like, oh well, maybe that's just the fire making its way to the front of the stove and the cabinetry and all that. Well, the problem with that is, as we all should have learned, and hopefully know, heat rises. Okay, so and that includes the same thing goes for fire, right? Not only does it rise, but it typically will burn in a V shape. So as it goes up, it will also spread out. So this creates a problem in this particular picture here. If it would have started, well, first of all, like I said, heat, since heat goes up, including flames, unless there's something else intentionally drawing it down, there's not, that's not going to happen. No, that heat is going to keep going up, and that flame would just naturally spread, like I said, up and out. So what this indicates is that someone had taken an accelerant to aid in lighting the fire, started it down here, and let it burn up into the stove area. Okay, so that's why you have some light charring here as it makes its way up, and then your more extensive charring because you have a lot more heat and it's that natural form of burning up or upward, I should say, and and causing this, obviously the charring, the black, in some cases will look brown or bluish, but either way. So key points here to begin with: V pattern, as that's how fire burns, and you see it over here in this vehicle also, right? So there's a V pattern, which would indicate that this fire likely started in the engine compartment here. Okay. Um, but what I was going to say, point number one, V pattern for fire. Okay. Um, and something else I want to point out, earlier I mentioned there's a difference between the different kinds of smoke that you may have, the charred smoke, the versus say white smoke and all that. Gypsum is and a good example, or drywall. Okay, if you think about that, um, if you're investigating fires, there are different levels of, like, it'll say, okay, slight char. Um, it will turn like a light brown and then a slightly darker brown color, and then it will go between like a bluish and black, and then, well, I should say that it gets to a black first and then becomes almost like a bluish color after that and becomes white. That's like that's the case with a lot of things when they burn, but gypsum or drywall is a great way to look at this. So you have some similar to up here. What you would have is, if you had truly complete combustion, this area up here would actually be um, almost, it would not be the same white that you would have here where it's been painted white, but like up here where you have drywall, um, you would have it, if it had burned all the way through and had all the way through, but if it had burned completely, in essence, okay, then you're going to have white that's left over as opposed to this dark color that just shows that there's incomplete combustion. Incomplete combustion may result from uh, not having enough heat, um, maybe not being able to, in essence, have that air escape. Um, could be a multitude of factors, but that's usually the issue with it is, um, there's nowhere for it to go sometimes up here once it gets stuck. That smoke uh, and incomplete combustion or incompletely combustible material will stay up here. Even though, like I said, once it gets hot enough, this stuff will burn to where it actually leaves almost, it's like an off-white type of color. Okay, but you don't have to worry about this one because, like I said, they got there in time where this didn't burn a whole lot beyond here in the kitchen. There was some smoke damage in this other room, but no major burning beyond what you see right here. Okay, um, that's the main stuff I want you to get across. Like I said, V pattern. Um, understand when you're looking at things. Understand what would be a natural um, place to have fire come. So let's just say instead of a kitchen, we would have, say this was a living room with an outlet, okay? Because people try to do this too. They try to blame it on uh, electrical fire in essence. Like, oh, there's a problem with a bad outlet. Well, if right here was where the outlet was, you're going to have that same issue that we discussed before. It's not going to burn straight up in a line, right? It's not going to burn straight up on even on your wall. It's going to have that V pattern. Now, and here's the other part. If your outlet was here, if the flame started down, or not flame, but if you see damage, and it hasn't been, in essence, burned out completely, which sometimes that destroys what you can actually see, or at least makes it much more difficult. But what I was going to say is if you have that fire damage below the outlet, if it were up here, then once again, that would indicate the same thing that we have here. Now, don't all automatically assume, for example, um, another point I want to get across with multiple packages. What we mean by packages or fuel packages would be something that is combustible. Yeah, with an arsonist, maybe it's um, another area where they've put an accelerant. Maybe it's an incendiary device that, for lack of better terms, explodes or combusts at a given time. All that kind of stuff. You know, set up on a watch could be set up based on something as simple as um, a cigarette or something like that. Okay. The issue you're going to have with multiple packages is, yeah, if you have these areas um, where you have, you know, say you have this pattern here, but then on this side of the wall you would have had another V pattern, okay? Or over here where you see the chairs, were they more like recliners and things like that, and you had one of them was sitting by the wall and you had a V pattern out of it, you're like, oh, someone might say, oh, well, that's multiple um, fire origins. That must be arson because that's not natural. Okay. Well, we'll get to that in just a few minutes about showing you what that can actually, you know, come from or what that would look like. But don't automatically assume that just because you have multiple origins where a fire started, that that has to automatically be arson. It can be, but it doesn't have to be. Something else I want you to be aware of is if you happen to see if you have carpeting or even hardwood will look a little bit different, but especially carpeting, and someone has taken, whether it be clothes, which would count as a fuel package, okay, and have taken clothes and they've kind of strung from one room into another, hoping that they catch fire and take that fire into the next room. Be aware of that. Also, same thing can happen with an accelerant. You know, someone takes, let's just say, gasoline. Um, Even though they'll probably choose something else if they have an option because it's not the best in the world to use. A little too volatile, and sometimes it evaporates kind of quickly to burn depending on the weather and the conditions inside. So, either way, you have fuel here where they made a trail. Maybe they went upstairs or from upstairs downstairs. But either way, those are things to look at. And they call the pattern that, you know, where it looks like they've taken an accelerant and poured it. Let's just say they poured it here in a pile, or in a, I say a pile, but they poured a pool of it here, or made a pathway into this other room. Those are called pour patterns because it will burn differently. Um, it will have more indications of not necessarily burning longer, but you'll have um, a little bit hotter of a burn, depending on how extensive the fire was, where that accelerant would be. But you will be able to tell by damage in the carpet to where it looks like I said, it's not natural for fire to burn in a true like linear path to where it's like, oh, well, it went from this room, and that fire's not going to burn naturally in a line straight to some other point. It's going to, it may burn this direction, but remember, it's going to spread while it burns too. So, I don't really need to spend a whole lot of time on this vehicle because I already explained the V pattern that you would have had from this general area. But I just wanted to show you on a vehicle what a V pattern may look like. Okay, different factors. I won't expect you all to um, remember all of these, but these are things that more so from a fire science or fire side of things. These are things that will affect how a building burns, um, speed at which it burns, direction the fire goes, um, possibly the heat or even how dangerous it would be on the inside. But there are some things I want to let's see. Um, Obviously, the higher level oxygen, the more fuel the fire has, so that would help it. So sometimes what you'll see is um, we'll talk about what kind of causes um, a, a backdraft, and I'll show you what that would look like, what it is, and why we need to be worried about it from a law enforcement standpoint. Okay, so but I'll talk about that with more so the idea of oxygen levels and pressure. So, wind will indicate. I'm sure most of you are aware of, if you've ever burned anything outside, burned leaves. If you've ever seen wildfires out west, for example, um, wind plays a big factor. Same thing goes for the house. If the windows are open on one end of the house and the wind blows into the house, it will push that fire in the direction of the other side, assuming that there might be another opening, like a window on the other side is open. If that wind is pushing through the house, it's going to push the fire. Like I said, if the wind's going from west to east, like it does a lot of places here in the Midwest, right? Um, Typically, then that fire inside the house or wherever you're at will burn to the east. So keep that in mind. The reason why we worry about that more so is entry. If we do need to go, if we arrive before the fire department gets there and we need to get in there to try to help someone, keep that in mind as well as just safety of anybody that would be in the area. Okay. Multiple packages. I've already kind of mentioned that about um, be aware that for one, yes, it can be a sign of arson, but don't automatically assume that there are multiple origins or multiple fuel packages, which is anything that is combustible, um, that can start fires in different places, right? And since fire doesn't have to be, it's not like by touch. It's not like, oh, fire, you can't get burned unless you touch the actual flame of a fire, right? If you put your hand above a flame, even if it's not in the flame but above it, you're still gonna, potentially get burned or hurt that way if you do it long enough. Um, like I said, you can do that. Also, ways fire just simply by the friction can cause or can be caused by friction, right? So that's something to be aware of. The packages, um, and I'll discuss. I'll show you what I mean by some of that. But when we talk about um, flashovers, when we talk about uh, how fire actually acts in small spaces or confined spaces. Um, so accelerants, I already mentioned the pore patterns that you may see. I also demonstrated, basically, not demonstrated, but showed you what it might look like if someone tried to use an accelerant and didn't hide it very well in terms of trying to go up a wall to or up a cabinet to a stovetop or something else where they like electrical outlets, anything like that, they might want to use as an excuse for the fire. And something interesting about surface area is, all right, so if you have, we'll just use something simple like a block of wood, right? If you take a block of wood that is, let's just say, um, a pound worth of wood but in a block form, right? And you take that same 1 pound of, or take that same block in essence, and turn it into, um, get it down into sawdust, right? But you have the same amount of um, wood and weight either way, all right? It's going to take less time for you to ignite the sawdust than it will uh, for you to ignite the wood, because the more surface area something has, the easier it is to heat up the area around it and make it more likely to combust. It, like I said, it just heats up the area better, and sets it up to be combustible at a faster rate. You may get charring, you may get heat from that block of wood, but the all the space that you would have in those individual specks of dust, or dust, specks of wood and sawdust, like I said, that's going to provide more space, more places for that heat to get to, increase the surface heat for each of those little bitty um, specks of wood, right? So um, the more surface area you have, the less time and less heat it takes to cause combustion. That's why, for example, if anybody's ever seen this, anybody's ever from, like anybody that would be, I hope it's never happened to you or your family members, but if you um, happen to have a farm where you grow corn and you put it in the grain bin, and it may not be, say the bin's not full, right? But you get a whole bunch of that dust that's built up into the grain bin itself, all right? And you get a thunderstorm with lots of lightning. You can actually, lightning can ignite, like if you get a lightning strike of that grain bin, it can almost act like an explosion, because you've got the right air mixture mixed with the heat of the lightning, for example. Um, a lot of surface area for that, dust, and it will ignite. There. Besides that, there are ways that, kind of same concept, but same type of explosion can occur in areas where you have, even in industrial areas where you have fine dust, that the material itself can be combustible, but once it's turned into either a powder or a dust form, and it's in the open air, and you have the right mixture, right temperature, um, and a heat source, okay, spark or whatever, right? That can actually cause combustion and an explosion in that confined space. So I just wanted to point some of those out, and I was going to show you these videos. Oops, I apologize for that. But yeah, this is like a pretty brief discussion about fire burn patterns and what to look for. Um, some other things before I get to backdraft is that some people automatically assume that, oh, I see a lot of charring, that must be where the accelerant was used. Not always true. It used to be an old saying that, uh, you could look at the alligatoring, in essence, that the charring marks on wood and determine if an accelerant was used. That's not entirely accurate. They'll be like, oh, well, it's deeper, so it must have been an accelerant. No, that's not true either. Essentially, when it burns and doesn't. Uh, Fire tends to burn at the same rate um, of whatever it's burning. So, like if it's burning wood, it will burn wood, um, a quarter inch of wood at the same rate whether or not you use an accelerant. The only thing accelerant does is it just allows for the flame to ignite sooner. And that's something else to be aware of. Not like I said, not like most of you are going to go into this or need to know this, but uh, that's another way that we test for the presence of accelerants besides using what we call a little sniffer, which is a device you can use to detect. And basically, it's like a portable device you can use to detect the presence of different chemical compounds that are typically used as accelerants. Okay. Other than that, you can look at an object, and the other reason why we can find accelerants is because accelerants are essentially hydrocarbons. And what happens is when you burn a hydrocarbon, um, the hydrogen and the um moisture, right? In essence, the water that gets mixed in there, in any of those, um, so that will get burned out. So the oxygen and the hydrogen get burned out, and it leaves behind a couple things. It will leave behind the carbon, hence the coal or charred items basically are mostly carbon. Okay, so there's the carbon, but then with hydrocarbons, sometimes you won't have complete combustion, right? So you'll have some of those um, hydrogens left behind. Some of the other compounds that you would find in a hydrocarbon would be left behind because for lack of better terms, the water has been boiled away, and now all you have is the residue of that hydrocarbon that's left. So um, that's what you can identify, and why you can identify something that even if it's burned up, you may be able to get for our purposes, for law enforcement, if we have uh, a piece of something that has been burned or partially burned that we believe that an accelerant has been used, we would put that in our little uh, metal, what looks like a paint can, right? Put that in there, sealed up, just in case there is an accelerant in there, and we don't want to have those chemicals leave, right? So we leave that in there and take that to the lab to get it tested. So either way, so that, like I said, that's a little side note that I'd let you be aware of it. And as far as backdraft, um, actually, I think what I'm going to do instead of showing you guys, let's see, yeah, I should show you. Shouldn't be a problem. Of course, it's going to be a problem here. So, what I will end up doing, because it will work if you try to do it, but on my computer right now it's not. What I recommend you do, I'll make this lecture, the PowerPoint available, not just the video of it, but I'll make this PowerPoint available. I recommend you watch both the backdraft video and the fire testing and patterns. And here's what I want you to look at. So, backdraft, essentially what has happened is you have a fire that's in a space. We'll just call it, it could be a house, could be any place like that, where the oxygen has been cut down on. So, for example, what would happen is when something burns in a confined space, you have that combustion that takes place, right? And as that combination of, I'll say, steam, air, and non, incompletely combusted material rises, just as the heat rises, right? It's going to reach say, a ceiling or a top of whatever it's in, and then it's just going to sit there, and you'll gradually see, and you'll see it in the fire testing video, where that line of, in essence, smoke, whatever, will keep getting closer and closer, like further down, closer to the floor. All right. So that's what happens is as your heat and incompletely combusted material rises and then it kind of layers on each other, there's less space for it to go, so it's increasing pressure. All right, so you have this is what causes blevies, right? So um, that's whenever like you have uh, liquids inside a container, gets hot, and then they eventually blow out on one end. That's called a blevy. But anyway, same kind of concept happens inside of um, inside of a house or whether it's enclosed. It can happen in any type of confined space. And like I said, as that pressure builds, because the increased amount of heat and pressure pushing down from the material that had been pushed up to the ceiling, but as it pushes down, increases heat, increases pressure, okay, and now you have less oxygen because as you're burning, right, you are burning up some oxygen, so it may not be entirely gone, but the amount of oxygen is preventing the fire from burning even more, right, or even hotter. So what happens is in a backdraft, um, a doorway, a window, or something to that effect, usually a doorway in terms of law enforcement. We arrive, okay, for some reason, if we get there before the fire department and we feel like there's someone inside or we need to check on that, there's reason to believe that there's someone inside. Um, if they're not paying attention, what they'll do is, they'll go in that, say it's a front door, you come to the porch, start to open up that door. What happens is when you open that door, you have all that pressure that was built up in the house and all that heat and everything, it is escaping, right? Just like, if you squeeze a water bottle when the cap is off, and then you take that cap off, excuse me, squeeze it when the cap is on, and then as you keep squeezing and take the cap off, there's going to be that pressure to where the air comes out, right? Or same thing happens. You can do the same thing with in different weather, right? In terms of take something hot and then put it in an area where it's a little cooler, it will emit that heat, right? So it'll get rid of that heat. Same concept here. So when you open that front door, and as law enforcement, you think you're going to go in, you have now allowed that pressure to be released, and you also have an inflow of fresh oxygenated air, right? So now what you've done is you have created an area where the air mixture makes it more likely and uh, is the proper um, concentration, in essence, you want to call it that, or uh, proper makeup and proper mixture to ignite. It's not like the fire, people say, oh, fire explodes out the door. It doesn't always do it immediately, okay? It may take a second or two or a few seconds. It can happen pretty quickly, but within a few seconds, what tends to happen is, like I said, as you have fresh air going in, old pressurized um, air leaving, right? You'll get the mixture of the two airs, and it will at some point become or can become ignitable, right? And what happens is it's not that the fire comes out of the house per se or out of the structure that it's in, but the air itself, because it's hot enough and because it has the right mixture, can essentially ignite. It doesn't have to have a flame do it, doesn't have to do anything like that. It will just ignite as it is, and it looks almost like some people might call it a fireball, but it doesn't really, that's not really what's going on, but it does ignite. And that's something you're going to see when we have this, when you watch that backdraft video. I want you to notice notice the difference between like the dark smoke you see and then the lighter, not quite white, but lighter smoke that you see right before it ignites. And in fact, if you look at it and can pause it in the right place, what you'll end up seeing is you'll see fire from the inside as a separate, it's igniting separately. And then right at the end, you'll see a space that's outside the container that will start to ignite on its own, even though the fire is inside the container. You'll see those two places light on their own, and then almost like they come together um, in a real quick. I mean, it happens pretty quickly. It looks like it's just being pushed out, and that and it becomes, it's almost like if you watch it in real time and don't know what to look for, it looks like you get a big push of smoke coming out and then fire follows immediately after it. But that's really not what's happening exactly. It's the, like I said, it's the um, igniting of that air with the right mixture. Just like we would have had with a candle, you can ignite it, but you don't have to have a flame, but you can ignite it simply with enough heat um, in the right air mixture. Okay, I don't want to beat a dead horse with that, so watch that. You can watch it in, it'll show it in slow motion, but then you can also stop it and pause it on your own. But that video, I believe, was made in both of them. I think you'll be watching made in Sweden, and the reason why is because that's one of the better testing outside the U.S. That's one of the better countries as far as regarding their fire protection studies and practices. So anyway, there's that. The fire testing and patterns. The only thing I want to point out for that one, they basically take a hypothetical room. They kind of set it up like it would be a young girl's room and show how a fire would progress. And to be honest, it doesn't. You'll find out it doesn't take long. Once a fire starts in a room like that, it does not take long for the room to be, for one, to be dangerous to be in there with smoke inhalation, and then two, fully engulfed with fire. You'll see what's called, in essence, a flashover, to where you'll have that fire go up. Um, and once you had enough heat on the ceiling and certain flammable things on the ceiling will suddenly catch fire, and it kind of, the fire, it's truly not rolling across the ceiling, but it does go across the ceiling pretty quickly. And then the other point I want you to pick up on is you'll see when there's, I believe it's a lampshade, um, or at least something from the ceiling that is dripping down um, from the ceiling down onto the floor and on other objects. Okay, but what I want you to notice from that is, yeah, it can fall on other fuel packages like clothing or furniture, whatever, and start a secondary fire that someone may come in later and say, oh, that's a, like we talked earlier, that's a secondary package, or that's a different origin. That must mean it was arson. That that's an example there where that arson would not have been the case. It was just simply fire that had been rolled across the ceiling, and while that heat is there, causing other things to begin to burn, it will some of it will drop down from something higher, whether it be a ceiling or anything else above the objects, fall on those objects, cause them to ignite, and like I said, that becomes a secondary origin. So anyway, that is kind of the rundown of what I wanted to show you or talk to you about with fire burn patterns. I know I didn't go over a whole lot, but as I mentioned before, that's the reason for that is just simply because exposure is great, but most of you won't be going into great depth with a lot of your fire investigation. So, um, if you have any questions beyond what I've covered, feel free to ask, and I can do my best to help answer your question.